Okay, can you all see the web page now?
Mm-hmm.
Okay, so
Yep.
for the first time, I'm trying a fancy thing with more than one computer screen. I don't want to just be trying to share your faces because that will look blank to you. But now if you're all confused, I can actually see that while I'm lecturing. And as a heads up, when I put yesterday's video up on YouTube, it randomly picks one screen to be like the thumbnail you see when you look at it, and it was a student's face. So just a reminder, if you don't want your face on YouTube, then be like the people who are just sharing their voice but not their video, because for helping people who aren't here, I'm going to be recording this. Okay, homework. So if you click on this dog homework page, I'm going to open it in a new tab, then I've reorganized that some. A shortcut, if you don't want to have your other mouse button to bring up that context menu, is in Windows, you do Control. On a Mac, you do a Command, and that will also open it as a new tab up at the top. So as I made a short video yesterday, actually, let me start over. I'm going to close all these tabs. So I want to do some homework. Then I'll go to the Math OER, and I want to open a few things. I want to open the textbook, and if I click on that at the top, it always opens a new tab. And then I'll go Control and do homework to open a new page there. When I scroll down a little, there's a place to jump at the top, so you don't have to scroll. Good for phones. But if I want to do some textbook problems, now we have nice links here for both of our books. And when you click on one, it says, here's kind of the best textbook problems to do, so you don't waste your time and do too many. With the online book, this is especially important because they use negative numbers and we don't. There's nothing in Math 60, there's nothing in nursing or culinary or all the other places that want Math 20 that cares about negative numbers at this point. So you might notice that we skip over all the negative number problems, and that's okay. Anyway, I want to start working on page 9. So I could go over here and put 9 in. And now I'm looking at page 9. If I wanted to see the odd numbered answers, I could open up the tools thing, go to supplements and selective answers. Unfortunately, since I just shrunk my screen, it repaginates. And when I close my tools again, I'm not at the right place anymore. So I have to say, I wanted 9, listen to me. And now I'm almost set up. I can go with these tabs to say, let's look at my notes, see what we were doing in rounding. Let's look at the textbook, let's look at the answers, and let's look at the best problems. But this is annoying to have to click at the tabs at the top to go back and forth. So for most browsers, you can take something and just kind of drag it off and it makes its own window. And then I can shrink this over here and this over here and say, okay, now I can say, here's the problems to do, here's the problems I'm looking at. I can have my calculator and my paper and pencil in front of me, and it's nicely arranged. I can see everything I want to at once. And I'll do a few problems, and then I can peek at the odd answers. And I'll do a few problems and peek at the odd answers. Any questions about how I made that happen on my screen? Because I want it to be equally friendly for you.
Nope.
No? Okay. Okay, but that wasn't your actual question. Now I've forgotten what your actual question was because I just did all that.
It was how to turn homework in.
How to turn homework in. Okay, so once I've done some textbook problems and I'm feeling confident that I know this stuff, then I will go back to that main homework page. Either at the beginning, click on the dog, or from anything, click on the dog up here. And I'll go down to the stuff to turn in. I can click on the link, or I can click on the picture. And then there's this folding thing called an accordion. So if I want to turn in the rounding homework, then I look at the homework and I do these 10 problems. And these are the first 10 problems you've seen that don't have answers in them provided for you. So I will do them here. And I give you this page because I want you to work forward. Start with the problem and try and find the answer. When you've done all 10 of them, then at the bottom, it says, after you're very happy with your answers, turn the rounding problems in here. And by very happy, I mean you should probably even check with other people. Maybe someone you live with, maybe someone else in a study session. But it's good to work on homework together. So if you have the schedule flexibility to be able to at least check things with someone else, if you can't even work together, then that's still good too. So then you'll click here and you get those same 10 problems, but now they have multiple choice bubbles. So you'll pick some multiple choice bubbles. And then when you say process my answers, then down here at the bottom, you can see a code. If you double click the code, Control C, copy and paste, put it in an email and send it to me. It helps me if you put the name of the email, like shapeshifting rounding, in the subject of the email, so I know what code this is for. What doesn't work for me is if everyone replies to the after class email with homework codes, because the way Gmail collects everything into one long chain of messages, then your code is going to get lost in a dozen other people's things they replied about. I have a question about the homework or some project or something. So, okay, did that answer your question?
Yes, thank you.
You're welcome. Okay, other homework questions, example problem questions, anything like that?
Can we review putting decimals in ascending order?
Sure. Actually, let me see if I have one in the book, because you've seen that one already. Page 3. Oh, actually, decimals would be the different page. That's 295. No, they don't have a good one for us. Okay, well, I'll just make something up. Okay, did I close my jam? I did. Come on, go there. Okay, how about okay, so here's 4 decimals. My general rule is I'm going to start on the left side and work my way right to find the biggest one. So imagine you have something really valuable. You know, somebody is sharing, I don't know, parts of a gold brick or something. So this column is our tenths column, and you want as many tenths as possible. So 2 tenths is going to be more than 1 tenth. So these 2 at the bottom are going to be bigger than those 2 at the top. Then I keep going. For now, I'm going to only look at the two that were the biggest ones because they had more tenths. So for hundredths, they have no hundredths. For thousandths, this one has 0 thousandths, and this one has 1 thousandth. So this one has more. So that's our biggest so far. And that means this other one that also had 2 tenths is going to be second biggest. Now I need to look at these two and do a tiebreaker. So they both have 1 tenth. That's the same. For this one, for hundredths, 8 hundredths is more than 7 hundredths. So this one is going to be bigger than that one. So third biggest. And then what's left is going to be the smallest. Should we do another example?
I think I got it. Thank you.
You got it? Okay. Other questions?
It seemed like in the textbook, as I was reading it and doing some of the problems, I believe it was just the rounding part, not necessarily in the order, but it had the correct answers, but the way they got it said that 6 was less than 5. So we would put it.
If they have an error, then, oh, well, I can't fix the textbook.
Right. But I mean, the answers were correct. It was just how they got there was confusing. And finally it was like, okay, yeah, this is the second time they've said that. And this is not smaller than, so.
Send me an email because I do have contact information for the textbook company. So
Okay.
We'll collect their little errors and then I'll send them eventually as one thing saying, thank
Sure.
you for sharing your book for free during the pandemic. Here's some things to fix that my class found for you. Okay, any other old stuff before we do new stuff?
I did have a question on number 1, 6, and 10 of the rounding decimals, I believe it was,
Okay,
for homework.
for homework. So which part of the homework? The turn-in problems?
Yes.
Okay, so turn-in problems. Okay, 1. What number is 212 thousandths?
So I thought that I got that right, but maybe the wording just has me confused.
Let's do it and see. Sometimes for ones you turn in, I will just, do them for you, and sometimes I can't highlight like that anymore. Sometimes I'll change the numbers so I'm not giving it away. But
Yeah.
for now, I'll just do this one. Okay, so it's going to look something like 212. My question is, where do I put the decimal place? So if I put it here, that would just be 212. That's not what I want. If I put it here, it would be 21.2. That's not what I want. This would be 2 and 12 hundredths, because the smallest decimal is the one we name. But 2 and 12 hundredths isn't what we want. If I put it here, that would be 212 tenths, hundredths, thousandths. So that's what I want, 212 thousandths.
When I was looking at it, I was putting the actual number with like a comma.
Yeah, it
And
could
so-
be.
Is it the wording
It's
that?
because of the THS. If we
Okay.
didn't have that, if it was just 212,000, we would have the bottom number.
Okay.
But since we do have that THS, then we're talking about the decimal place.
Okay. Thank you.
You're welcome. That was number 1. Which other ones?
I had number 6.
Number 6. Okay.
Yeah.
I can just squeeze that in there. Okay, so I want to look at place value. Tens, hundreds, I'm sorry, ones, tens, I must leave still, hundreds, thousands. So I'm going to round it to the nearest thousand here. And that means I also want to look at the number just to the right of that and check, is this one 5 or more?
Oh, it's less than 5.
Less than 5. So that means that my 54 is going to stay how it is, and everything else is going to get wiped out.
Oh. So then again, that has to do with the wording of the
Okay.
problem.
If it was a different problem, if they did ask us to round to the nearest thousandth, then I would be going tenths, hundredths, thousandths here.
And that's what I did. Yeah.
And then I would say, well, these two get turned into nothing.
Okay, that's what I did for the problem. That's why I was probably so confused.
Yeah. The TH at the end is the reason we do these.
Okay.
Okay, good, good. What else? There was one more you said. 10?
Yeah, it was number 10, and it was just
Which garden? These two. Okay. So it's asking when we estimate, we're going to cause some error. So which will be closer to the real number? Which one are we changing the least when we estimate? So let me grab that. So this is really close to 3. That's pretty good. And this is about 9 hundredths away. So here we're about 9 hundredths away from where we should be. Here we're about 4 hundredths away from where we should be. So that's pretty small. Let's check the other one. This one, we're off by about 3 tenths, going from 0.7 to 3. And from here by about 2 tenths, going from 0.2 to 0. So Alicia's numbers, when we round them to 3 and 1, we're going to be off by several tenths. Whereas Ben's numbers, when we round them to 3 and 1, we're only going to be off by a few hundredths each time. So Ben's estimate will be closer.
okay.
Again, that's because the 0, it already has the right number of tenths. Or the 9, to go from 91 to 100, we only have 9 hundredths that we have to stick in there.
So the tenths is more than the
Right.
tenths is more than the hundredths.
Right, we're changing it more. Would you rather have a tenth of a gold bar or a hundredth of a gold bar? The tenth is a lot more. For some of these numbers, pi is kind of silly. You know, a hundredth of a pi would be not a real serving. All good questions. Anything else? Okay, then let's talk about new things. So, last time we did decimal accuracy, we did estimating, we talked about division, that not only can you deal out objects like dealing out cards to friends, but you can make piles of a fixed size, which sometimes works better. We talked about those finding factors rules, which will help us when we're playing with fractions later. And we just started about how to make denominators the way that you wanted. So sometimes these pictures help people, sometimes they don't, depends on who you are. We talked about unreducing and reducing, and don't just put one little divided by or times by a number in the middle, but instead write things correctly. Does all of that ring a bell? Any of that you want me to talk about again? output. Okay. And I think this is where we ended. So here's a monster one. Let's do this. Good review of everything. So first I'll do this the long way, pretending I don't actually have a nice calculator. Then I will show you the cheat with the calculator. So we could just start with divided by 2, top and bottom, whittle this away very slowly, and eventually we would fully reduce it. I'm going to use the calculator a little bit as needed to be able to take off bigger chunks if we can see that something bigger than 2 is a factor of both the top and the bottom. So can we see anything bigger that would work, top and bottom?
Six.
6. We had seen the divisibility rule last time that, pardon me. Mute myself. Okay. The number is divisible by 3 if the sum of its digits is divisible by 3. Remember that one? So when I look at these numbers, 3 and 3 is 6. So yes, 3 goes into that. 4 and 6 and 2 is 12. Yes, 3 goes into that. There was a similar rule of if 9 goes into the sum of digits, we could do 9, but 9 doesn't go into 6 or 12, so it doesn't work in this case. We also had the rule that if 2 and 3 both work, then 6 works. So these are even and 3 works. So we can do a divided by 6 to take off a bigger chunk. Okay, I'm going to write this one way. So I'm getting 55, 77. Does it help anybody if instead of writing it all in black ink, then I take what we're doing to change things and put that in a different color? Does taking a moment to change colors help people make it legible, or is it just as good the other way?
It helped me, I don't know.
I heard some people say it helps them, so.
Okay. Oh, I forgot to turn on chat. So let me stop my share for just a moment so I can get chat out. Okay, no homework is due yet, so do as much homework as you can, but okay, back to this. Okay, I'll keep going. So 55 and 77, it looks like those are things that I can do divided by 11. And then we have 5 sevenths. Questions about that one?
Let's just say for a second that it wasn't obvious that 11 went into 55 and 77 equally.
Mm-hmm.
How would you find that 11 did go into those?
There's no easy rule for 11. So there's some cute tricks that didn't show up on this page. Like there's a cute trick for 8, but it takes a long time. So it's not helpful, it's just cute. And 11 is similar, so. But
Okay.
In real life, you have a nice calculator. So I am going to turn on my phone like a doc cam again. And mute myself here. Oops, I was muted. Okay, let me try that again. So if you can see this, if there's enough light, there's a key that says A, B over C. So I could put in 330, whoops, 330, hit the A, B over C key instead of a fraction bar, do the 462 and hit equals. And it gives me 5R7, which is its way of saying 5/7. And if I wanted a decimal, it also, after the equals key, goes back and forth between decimal and fraction. So if your calculator has the A, B over C key, that's a great thing. Okay, done with that.
I didn't see anything done on your phone. I just continued seeing the number 44 problem the whole time.
Same here, yeah, it was just the 44 screen.
Okay. Can you see the calculator and hear me now? I'm sorry.
Yeah.
Here doesn't match you when I'm using two things. Okay. So there's this little key that says A, B over C. I'm not good at holding up a phone. So that's my magic key. And I use that instead of a fraction bar. So I would take the 330, hit the A, B over C key, and hit the 462. And then when I hit equals, it's 5/7. The R is its way of saying fraction bar. After I've hit equals, it goes back and forth, decimal, fraction, decimal, fraction. So not all calculators have that nice A, B over C key, but the ones that do, you can either simplify a fraction automatically, or after you do some other problem, go back and forth, fraction to decimal. Okay, did that work for everybody?
Yep.
Oh. So the good news is you actually in real life almost never have to reduce fractions. So if you ended up with 5577, then I'm not sure how that would wreck your life at all. But if you have the calculator, then you can use that AB over C key. I can just make a little note here. Some calculators have AB over C. Okay. Are we done with that? Everyone's happy? I could reduce another thing if you want.
Yes, if you could reduce another thing. I can't see your board either.
You can't see my board. Let me share my screen again. I'm sorry, I'm not yet in the habit of having to turn on and turn off share screen. Okay, what's another one to do? $181. This is wanting to just end. Okay, nope, I'm wasting your time. Okay, let's just make one up. How about, actually we have random problems. Why am I looking at the textbook? Oh, we haven't done one with a decimal yet. Let's do both of these. Okay, so for number 5, 32 over 56. How should I start?
Divide by 2.
Sure. So half of 32 is going to be 16. Oops, why did I write my equal sign way up there? And half of 56, well, half of 50 is 25, and then half of 6 is 3, so that's going to be 28. So they're both even. Let's keep whittling away at it. They're both even. Ta-da. Number 6 is going to be a little trickier. Okay. Anyone need this slide more before I move on? Okay, I don't think we've talked about this yet. So for number 6, I have a decimal in there. That's annoying. How do I get rid of a decimal?
Round up.
Round up. I don't want to change my number. So I want to be accurate, not round
The
things.
decimal over.
Yeah, I can multiply the top and bottom of a fraction by the same thing. And 1 decimal scoot is the same as a times 10. If I do it to the top, because I want to, then I have to be fair and do it to the bottom also. So I'm going to get 48 over 340. Because when I scoot 1 from a decimal place that's hiding after my whole number, then I get 0 there. Everyone okay with what I have on the board so far? Then, now it just looks like something I'm familiar with. 48 over 340. I can divide top and bottom by 4. That's going to give me 12. And whatever 340 divided by 4 is. 85. Am I done? Well, they're not both even. Does 3 work? 3 works for 12, but 8 plus 5 is 13, so 3 is not going to go into that. 4 is not going to work. 5 doesn't go into this. This one only has 3 and 4, so if 3 and 4 don't work on 85, then yeah, I'm just done. So this is our decimal thing. If I had a different problem, if it was 4.08 over something, then I would need to do 2 decimal scoots to top and bottom. Does that make sense? However many scoots you need to clear out whatever decimals, then that's what you do to both. Okay, I'll get rid of that so I don't confuse people. Should we do more? Oops, I can't hear Spring.
What if you had a decimal point on the bottom?
We could do exactly the same thing. So let me make up a new random one. And just flip it if I need to. So 44 over 9.6. So 1 decimal point is sufficient, 1 scoot. That's the same as a times 10. So I have to do it on the top also, to be fair. So that's going to make 440 and 96.
What I was asking, I'm sorry, was what if you had the same, let's say 4.4 on top and 9.6 on the bottom?
Ah, sure, we could do that. So let me back up a little. If there was a decimal point here, then in a way it's easier because the same scoot is going to clear both of them and I have nice small numbers. Instead of 440 over 96, now it looks nicer. That's going to be what, 19? Did I do my mental math right? Oh, 24.
Yeah, my calculator said 24.
I was trying to be too fancy with my mental math. Okay, there we go.
Could you also go back and do the one that we just did that was 440 over 96?
Yes. So if you started with 44, then when I did my scoots, 440 over 96. It still looks like I can do a divided by 4 top and bottom. Remember that rule of you only have to pay attention to the ones and tens. So this one only has 5 and 11 as factors. The bottom only has 3 and 4, or 2. So nothing in common. We're done. Okay, all good. Everyone's happy?
Yeah, will we get into if you have, say, hundredths and tenths? Will we get into that eventually?
For this kind of thing? Don't think so. I think the most we do is just what I'm giving you now.
Okay.
So. Okay, so that was about reducing fractions, and that's kind of as hard as they get in this class. The next thing we want to do, again, for now we're focusing on everything we might want to do with just one number, is take our fraction and make it a decimal. So if I have a fraction, like let's use 0.08, then there's different names for this. If I'm just working one-on-one with someone in a study group, helping my kid at the dining room table or something, then I could just call this 0.08. And everyone knows what I mean. If I'm lecturing, as I mentioned last time, I'm going to call it 0.08, just because saying that initial 0 gives your ear or your eye a little more heads up that decimal is coming when I'm giving a lecture. If we want the formal name, if we were a stenographer in a court of law or something, then you would say this is 8. And now is this one going to be 8 tenths or 8 hundredths?
Hundredths.
Hundredths.
You say the name of the smallest place value that's there. So all of those are perfectly legitimate names for this decimal. It's just sort of how formal you want to be. Is it wearing a t-shirt or a suit? If I want to take a decimal and turn it into a fraction, all I have to do is say that formal name. So once I have said 8 hundredths, then I can write it as 8 hundredths. And it's almost like I'm done. I've made it a fraction. That was my job. Except there's this annoying rule that fraction answers don't count as being done unless they're fully reduced. So I have to keep going. So these were my steps again. I say the formal name, I write what I just said, and if I need to reduce it, I do. The other example was this thing, 0.125. I can go back to the previous slide if anyone needs. How do I say this one?
125,000.
Yeah. Oops, why am I writing an I? Would I ever actually write it out like I am doing now when doing homework or a test? No, of course not. I would just say it to myself. I'm only writing in green right now because I'm lecturing. So it's 125 tenths, hundredths, thousandths. So I will just write that, 125 thousandths. So how many quarters are in a $1.25 for the top?
5.
And how many quarters are in $10 for the bottom?
20.
So I need to keep going.
1/4.
Yeah. Again, I'm not going to try and do all that baloney with my phone, but if I put in 0.125 and hit my, I guess I have to do equals first. 0.125 equals and hit my AB over C key, then it's going to, whoops, it should be 1/8. What did I mess up on? Oh, because I trusted someone here. So that's 40. Each dollar has 4 quarters, so $10 would be 40 quarters. Okay, now that they're both right, anyone have questions about either of these?
What did you do in the calculator? You put 0.125 equals.
Since I have the AB over C key, I did the 0.125 equals. And then I could use the AB over C key to flip back and forth between decimals and fractions.
Yeah, my key to, like when I hit the ABC key, it doesn't do that.
Did you hit the equals after putting in the decimal?
Yeah,
I don't know.
weird. It just says degree at the top of the number.
Yeah, but it should always say degree if it's a normal calculator. Show me after class, hold it up to your webcam, and
Okay.
we'll see what we can do. Okay, so that's slightly annoying because of this rule that we have to reduce fractions, but other than that, not too bad. Going the other way, to change a fraction into a decimal, we just treat it as a division problem. So if I have 1 divided by 5, put that in my calculator, do a long division if I really wanted to, and I could get 0.2. 3 divided by 8. So that one's even friendlier. Don't have to worry about reducing things then. Wherever you see the fraction bar, do division. Work your way sort of top to bottom. And of course, you can go back and forth to check your work. You could say, is it true that this one is 1/5? This is 2/10. And yeah, if I divide top and bottom by 2, I get to the 1/5 I started with. So you can check your work. This cleverness thing says that sometimes we can be cute and show off how smart we are. If I have something like 1/25, and I want to make that a decimal, I could notice, hey, 25 I can turn into a power of 10, into 10 or 100 or 1,000 or something. If I did a times 4 top and bottom, then I get 4 hundredths, and I could write that as 4 hundredths and be done. But that's not really a shortcut. It's just like bragging, because by the time you noticed that I could take 25 and make it 100, someone else has taken out their calculator, done 1 divided by 25, and gotten the same answer much faster. So if this makes you feel good to do it this way, you can. Maybe you've been taught this way before, but in general, whenever you're trying to get a fraction and make it a decimal, just do top divided by bottom. Sometimes decimals repeat. And first I have to talk about how to write them. So if you haven't seen the little bar over numbers. And let me talk about that because not everyone has. I could have a decimal that starts out 0.321 and then just keeps going with ones. If I wanted to write that and be clear, I would put a bar over the top of the 1 to say that that part is what keeps going and going. I could also have a decimal that keeps going back and forth just between the 2 and the 1 and the 2 and the 1, back and forth and back and forth. Then I could put my bar on top over the 2 and the 1 to say that's the part that keeps going. Or I could have a decimal where all 3 digits keep cycling, 321, 321, 321. So I could put a bar over all 3 of them to show that that's what's happening. If I just wrote 0.321 dot dot dot, I wouldn't be sure which of these 3 things on the left I meant. So to be careful, when you need to be careful, that's what this little bar on the top thinks. If it doesn't matter, then I will sometimes be lazy and do dot dot dot. If I write 0.9 dot dot dot, you know it's 9s forever. There's no ambiguity there. But technically I'm being sloppy if I was to do that. Everyone okay on the bar on the top notation if we need it?
Yep.
So 3 of these are important enough that for one direction, they're worth memorizing. If I want 1/3, and I want to take that and make it a decimal, I can just do top divided by bottom and I get 0.3 repeating forever. If I want to do 2/3 and make it a decimal, again, I can do top divided by bottom and I get 0.6 repeating forever. If I want 1/6 and I want to make it a decimal, same thing, top divided by bottom, no problem. I get 0.16 and the 6 part repeats forever. Your calculators could do this, no problem. The difficulty is going the other direction. If I see 0.33333 forever and ever, it has no formal name. Going back to all of this stuff we were doing here. It is not 3/10. It is not 33 hundredths. It's not 333 thousandths, right? Whatever I try, there's actually more 3's there. So my tool for going from a decimal to a fraction doesn't work. And for repeating decimals, normally we just say, who cares? But for these particular 3, we'll use them enough that it's worth memorizing this direction. If I see 0.3's forever, that's 1/3. If I see 0.6's forever, that's 2/3. If I see 0.1666666 forever, that's 1/6.
Are those the only 3 that do that like that?
Nope, anything that involves thirds and sevenths and odd numbers on the bottom will often do that. So, things that don't fit well with 5s don't, because they fit well with powers of 10. What am I trying to say? Going from decimal to the fraction. There is a way to take a repeating decimal and make it a fraction, but it's sort of math 60 stuff. So I'm not going to show you that now. If you hit toggle answer, you can see what happens if you really care. That's something I would do in a study session if you want, but I don't want to take normal class time with it. Okay, questions about anything we've done so far? Everyone's quiet. Okay. The next thing, our next subtopic is ratios and rates. Some of our fractions are different than other fractions. Math, if you haven't noticed, can be really weird. If you go to someone that is a math person and you say, is this a number? Then they will say, yes, 4 is a number. Everyone agrees 4 is a number. And if you ask a math person, is this a number? They will say, sure, a quarter is a number. And some people might disagree. If I was to ask a second grader, they might say, no, this isn't a number. This is like a problem to solve. I'm doing 1 divided by 4 or something like that. If you go to a math person and say, is this a number? They're going to say, no, it has an addition sign in it, which seems unfair because this had a division sign in it, but we let that be a number. So why isn't this one a number? Especially if you say, is this a number? The math person will say, yes, 3/4 is a number. I can put that on the number line. So sort of what counts as a number is bizarre if you stop to think about it. And the reason it works like that is because the kinds of things we do in real life with ratios and rates are different than the kinds of things we do in real life with plain numbers. But since mathematicians do things with ratios and rates all the time, then they mentally categorize them as numbers. So they will say this is a number even though this isn't. So let's talk about what we actually do with ratios and rates to build some of that up in your mind too. So far all of our fractions were proper fractions like cake slice numbers. The denominator says how many pieces there are, and the numerator is how many we care about. So if I write 3/4, there's 4 pieces of cake, and there's 3 pieces that are mine or that we haven't eaten yet or something like that. That's sort of how we're all taught to think about fractions. Many real life fractions aren't like that. They don't have a sense of total pieces and shaded pieces. So we've seen that fractions can be like division, but fractions aren't entirely like division. If I have 10/5, no one does that with 10 divided by 5. Let's reduce the 10 and the 5 and make 2 divided by 1, and then we get to 2. No, we just do 10 divided by 5 as 2, and we don't reduce things. So we behave with fractions differently than we do with division. So if I have 24 energy drinks, let me just actually take all of this to write on. And $35.99, then we could say that this is $35.99 for every 24 drinks. If I wanted to, I could do 35.99 divided by 24 and see that it's about $1.50 per drink. But does anyone care? Maybe it's good enough to think about this comparison. Maybe the next question isn't what does 1 drink cost, but how much do 100 drinks cost, or something like that. Similarly, a contractor might say it costs $2,800 to install a 120-foot long fence. We could work out $1 per foot, do the division. But maybe no one cares. Maybe it's a different thing. Maybe we're going to say, well, how about for 500 feet of fencing or something? So we're sort of lurking. We have a comparison happening. We can write it like a fraction, but I'm not really sure I want to do the same kind of stuff with it that I would do with a fraction of making the decimal value of. So that's what we're going to call a ratio. Notice this isn't like cake anymore. It's not like we had 24 drinks and somebody gets 12 of them. Or we had 24 drinks and someone gets 2 of them or something. We're comparing totally different things, dollars and drinks. So a ratio is a comparison of 2 numbers, usually written as a fraction. Some ratios have that sort of cake sense. If we say 10 dentists are interviewed, 8 of them like a certain breath mint, we could write that as 8 over 10, and that seems happy and familiar. The 8 on top is how many are sort of special, the 10 on bottom is how many total. But we could also have a ratio, some that you're very familiar with, that aren't like cake slices. If we're going 38 miles in 40 minutes, if you're driving on the freeway at 55 miles per hour, it's not like the top is how many pieces of the bottom we care about. Some ratios even have a hidden sense. So if I have a classroom with 4 left-handed people and 16 right-handed, assuming no one's ambidextrous, how many people are in this classroom?
20.
20. But we're not writing the 4 out of 20 anywhere. We're not writing the 16 out of 20 anywhere. So this isn't the same kind of cake slices fractions that we're used to thinking about. So that's what ratios are like. We haven't really talked about what they're for. Often we measure real things. It doesn't make sense to reduce the ratios. Could I take 4/16 and reduce it to 1/4? I could, divide by 4 top and bottom. But that's not real anymore. It's not like there's a room with 1 left-handed person and 4 right-handed people. The real life situation was there were 20 people in the room and there was 4 this way and 16 that way. So sometimes if we reduce or unreduce, we're lying. It might be okay with the math, but oh well. Some ratios have labels. So we put words on it. We put words on it. If we put words on it, we call it a rate. The rate is the kind of ratio in which we label things, and they will have different labels. The most useful kind of rates are the ones we call unit rates. And you see this all the time when you're grocery shopping. You go to the grocery store, you want to buy the cheap vanilla ice cream, and the grocery store wants to make this tricky. So for one thing, they will label it in dollars per pint. In another one, they'll label it in cents per gallon. In another one, and so on, so that you can't easily see which is the good buy. If I have something that's not a unit rate and I want to make it a unit rate, then I can always divide. So if I have the 18 green and 9 yellow, if I do top divided by bottom, just like we were talking about before for how to make any fraction into a decimal, that's going to be 2 greens for every yellow. You might say, I don't care about green and yellow candies. Let's do a different example. So sure. If you're driving all the way to Portland, anyone know how many miles it is off the top of their head?
Isn't it about 120 from Eugene?
Roughly, yeah. So I'll just use 120. If I'm driving 120 miles and it takes me 2 hours, again, top divided by bottom, just like any fraction to decimal. I'll get to, oops, not 2, I've got 60. Miles per hour. So we do this all the time. We measure things and then we do top divided by bottom to get the unit rate for what it costs or how fast we're going or whatever the situation is. Questions on this slide?
No.
Okay. Oh, Josh said in chat 200 miles. Okay. Don't think it's that long. So we could do another one. So we have 300 pieces, 90 minutes. Top divided by bottom, 300 divided by 90, about 3 pieces a minute. Should I round this? Could I write 3 pieces a minute? Sure. Remember our general rounding rules. When the numbers, if the situation doesn't clearly tell you based on equipment or something how accurate to be, use the same number of decimal places, so none, or add one more, because when you make little piles out of things, then you do tend to be a little bit more accurate. So either of those would work. So far ratios and rates aren't bad at all. To make a ratio, you just write 2 numbers on top of each other. There's not even really any math. And if you want to make a unit rate, then you just do the top divided by bottom and your calculator does that work. Here's a tricky part. I want to shop for things and find the better buy. This is only tricky because there's more than one of us in the classroom and brains work different ways. Some people like to think about amounts divided by dollars. So if I want to say, what's a better deal? 10 ounces for $5 or 24 ounces for $8, they're going to do ounces divided by dollars. The first one is 2 ounces per dollar and the second one is 3 ounces per dollar. Everyone okay with what I'm looking at here? So this is like shopping at the gas station. I show up, I hand the $1 bill to the person at the gas station and I say, I want as much gas as possible for this dollar. This person is going to pick the bigger number to get the most ounces for their dollar. Some people say, wait a minute, my brain works differently. That seems totally the wrong way to do this. I want to start with the dollars and divide by the ounces. We're going to find money per ounce. So same thing, they're just flipping the order. When they do the division, they get $5 divided by 10 is 50 cents per ounce, or $8 divided by 22 is 33 cents per ounce. So this is like going to the bulk section of the grocery store. So I'm going to say, whatever, I need shredded coconut for a certain recipe. I never have shredded coconut at home. I'm going to buy 1 ounce for this recipe, use it up and be done with it. I don't want any extra. So I will just measure out the 1 ounce from the bulk bin, and I want to pay the least amount of money for that. It's the same answer. It's true for both of them that they picked the second option. But depending on which order you divide, you're going to pick either the bigger or the smaller result. So the lesson is do a few homework problems, figure out which way your brain works, and then focus on that. Ignore the other one. Don't confuse yourself. Did I say that well enough?
Makes sense.
Sort of, if we were to raise hands, I think most people like this one, but it's not a huge majority. What you don't want to do is swap back and forth every homework problem. Okay, we are done with that section. So back to our table of contents, we've now done all of these parts of fractions. Everything you might want to do with one fraction, we've talked about. We could make it a decimal, we could reduce it, we could unreduce it. We can think of it as a ratio or a rate, so things like that. Let's look at some homework. So I'm going to skip that one because that's annoying. How many factors do things have? Prime factorization, greatest common factor. Did we talk about greatest common factor? Don't know if we did. Let's do that one.
I'm good.
No.
good thing to talk about. Okay, there's a few ways to do greatest common factor. The first step is not to get confused and try and find the least common multiple. It's just part of how our brains work that anytime you see one of these problems, then you have this nice chance of trying to solve the wrong kind of problem. So we're not finding multiples like 60, 120, 180. We're finding the factors, the small ones that go into these. So I could just start listing the factors. I could say for 156, then that was, whoops, let me write it a little bit. 1 and 156. Does 2 work? Sure, 156 divided by 2 is going to be 78. Does 3 work? 6 and 6 is 12, sure. 52, and so on, and find all the factors for 156. And then I could do it again for 60, 1 and 60, 2 and 30, and find the biggest thing on both lists. But as you can imagine, that's going to take a while. There must be a better way to do it. Everyone with me so far?
Mm-hmm.
So what is the trick? What's the nice trick to do this more efficiently? So if there were factors in common, then there'd be prime numbers in common, like 2 goes into both of them. And I can take prime numbers and squish them together to make bigger numbers. Remember the divisibility rule that 6 goes into something if 2 works and 3 works? That's true for both of these, by the way, right? 2 works because they're even, 3 works because the sum is either 12 or 6. So I know 6 goes into it. I'm putting the 2 and the 3 together. I can just do that on a bigger scale. I can find the prime numbers and squish together the ones that they have in common. So I can take my 156 and make a factor tree. So that was whatever, 3 times 52, 2 times 26, 2 times 13. So there we go, all my prime numbers there. I can take 60 and make its factor tree. Then I take all the ones they have in common. So they both have a 3. They both have a 2. They both have another 2. They don't both have a 13. They both don't have a 5. Then I will take the ones they have in common and multiply those together. And that will be my answer. So it's still not quick and easy, but at least I don't have to make every factor of every number and see what's on the lists. Let's do another one. Everyone ready to move on? So for 15, whoops. I have only 3 and 5. For 42, I have 6 and 7, which is 2 and 3. So the only thing on both lists is my 3. The 5 isn't on this list. The 2 isn't here. The 7 isn't here. Does it help if I put a red X on them? I don't know. Anyway, 3 is my answer. Let's find another one, because that one was kind of quick and easy. I now need to go back and start my second board. So for 100, I can do 10 and 10. 2. Okay, did I make any mistakes with my mental math? Or my factor trees good?
Isn't 52, isn't 2 times 52 104?
Oh, yeah, yep. I thought I was wrong. Okay. That should be a 51, which I think is prime. I was doing a more interesting problem. Oh, well. Okay, so we have a 2 in common. We have nothing else in common, so 2 is going to be it. Let me do the other one that I wrote by mistake, just because it was a better problem. So if we have 100 and 104, factor this a different way just for variety's sake. Okay, so in this case, I have 1, 2 in common, another 2 in common, the 5s, no 5s over here. Is there a 2 to match that one? Nope, we've already used up all the 2s. Is the 13 there? No. So I'm going to get 2 times 2 is 4. Okay, questions on any of those? Any slide you want me to go back and see?
So on the first problem, when it was 100 and 102, the answer was 2, and we didn't multiply anything. But on the second problem, where it was 100 and 104, you multiply 2 times 2. Is that because there's a 2 on both sides?
Yes, each factor tree, I have to multiply all the things that were shared with the other factor tree.
And since because that one, there was 3 on the right-hand side, there you cross that one off because there's not 1 to match it on the other side?
Right. There's
But if
no
it would have been, then it would have been 2 times 2 times 2?
2. Yep.
Okay.
Just like, did we have 3 anywhere? Just like here, if there's 3 numbers that they share, I have to multiply all 3 numbers.
Okay.
Okay, does this ever say least common multiple when I do this, or is it all greatest common factor? We should talk about least common multiple too. Okay. So this is a similar thing, and the trick looks similar, but we're asking a very different question now. If I have, say, 24 and 60, I could list their multiples, 24, 48, 72, 96, and so on, 60, 120, 180, and ask, when is there something that's on both of these lists? Which number is bigger than what I started with, that if I keep making multiples, they'll have it in common? And I want the smallest of when that happens. It's sort of the opposite question of which of the factors do these things have in common that are smaller than them? And when I find more than one, like 2s and 4s, I'll take the biggest. So if I want to find the least common multiple of two things, then there's a trick to that. I'm going to make my two-factor trees. And as before, I'm going to circle the ones that are in common. So 2s were in common, a 3 is in common, another 2 is in common. And this time, instead of crossing out the ones that don't have a partner, I'm going to flag them with a different symbol, like put a box around them. And then my trick is anything that I circled because they share it, I'm going to keep multiplying those together, just like I did before. But now the ones that have boxes, I have to multiply by those also.
What about the 6? Because they both have a 6 in
I'm only
common.
caring about the primes.
Oh, okay.
Because remember we talked last class that I'm going to miss numbers, like 8 is a factor of 24, but there's no 8 here.
Oh, yeah.
So factor trees are unreliable for producing anything but the prime numbers at the bottom.
Okay.
So what did I get for that? 2 times 3, oops, on 2 times 3 times 2 times 2 times 5, give me 120. So if I didn't write these red numbers, I would find the greatest common factor. But by taking every prime number leaf of the trees that wasn't shared and also multiplying by them, I get something that is always at least as big as one of these, usually bigger, unless one's a factor of the other, and is the first multiple they have in common if I was to keep my lists going. I can spoil the party, or not spoil the party now. If I kept going, then this would get to be 96 and 24 is indeed 120. If I didn't stop early on purpose, I could have said, aha, and there is my least common multiple, the smallest one on both lists.
What are you multiplying by to get, you like just by itself, like 20, like, I guess I'm confused, like as you're going along, like are you just multiplying it by itself?
Yeah, 24 times 1, 24 times 2, 24 times 3. You could also just do a plus 24 each
Okay.
time.
Oh, okay,
So
okay.
it's like, you know, counting by 2s, 2, 4, 6, 8, 10, except by 24s. So. Okay, you don't have to memorize this one much now. We'll use it when we start talking about fraction addition. But the greatest common factor will, I think, use a little sooner. I'm not sure. Anyway, but they're so similar I wanted to show you them at the same time because it's almost the same process. Find the factors in common, multiply them together, and either be done or a little more. Okay, anything else that's a problem for you? Money divided by ounces. Sometimes after you find a unit rate, you have to do a little bit more work. So here is a snail. It crawls 60 yards in 10.8 minutes. So we did a bunch of these, top divided by bottom. And 60 divided by 10.8 gives me about 5.6 yards per minute. But that's not what it asked us. It asked us how many yards would it crawl in 96 minutes. So what I actually want to do is not round this. Let's keep it as the annoying repeating decimal I had. And then I'm going to say, because of the 96 minutes times 96, and I get about 533. So this one I'm not rounding because I don't want to round in the middle. That changes my answer. It's actually not any more work to not round because my calculator, when I do the 60 divided by 10.8, has that repeating decimal in it. I can just hit it times 96 equals and ta-da, right? So I just keep going with the calculator here. Everyone see why we're multiplying by 96?
Yeah.
Okay. Any of the rounding ones that were, no, I think we're good. Okay, well, I'm slightly hesitant to keep going, but I think we should. So we've done all of rounding. We've done all of fractions. Let's talk more about the decimal point scoots because that fits in with what we did already anyway. If I was to take a calculator and do this multiplication, I would see that if I take a number and I multiply it by times 10, actually it's really big. And a times 10 just causes one scoot to happen. A times 100 will cause two scoots to happen. And a times 1000 will cause three scoots to happen. So that's sort of our baseline thing. When I multiply by 10 or 100 or 1000, it scoots the decimal as many places as there are zeros. So there's two ways to tweak this. The first way is instead of times, we divide. So let's look at that. If I divide by 10, who knows what will happen?
The decimal place will move to the left.
Yeah, instead of going to the right, getting things bigger, it gets smaller. If I divide by 100, instead of 1 to the left, it's going to be, instead of 2 to the right, instead of 2 to the right, it will be 2 to the left. And 1000 is still 3 scoots, but again, it's the other direction. Everyone happy with both of those so far?
Mm-hmm.
So this was our basic one. We messed it up by doing division instead of multiplying, and we saw that it goes the other way. Again, if you don't trust me, try it on your calculator. The other way we could mess it up is instead of 10, 100, 1000, we could do this decimal powers of 10 instead of the whole number of powers of 10. So who knows what happens now? If you're not sure, try it on your calculator.
The decimal place moves to the left.
Yeah, it's the same pattern, 1 scoot, 2 scoots, 3 scoots as we saw in the previous slide. And it kind of makes sense. If I have 123 candies, because my kids did great at Halloween, and I give 1/10 of them to someone, that person gets 12 candies. Similarly, times means of. So this is also saying what is 1/10 of about 123? It's also going to be about the 12. Okay, now if we were actually in the classroom, I would have a brave volunteer come up, but since we don't, then I'm going to conscript Peter Rabbit. This was my older boy's favorite stuffed animal that he slept with for years and years and years from when he was absolutely tiny. And if you are about to become a parent, whatever small animal your kid is going to hug forever, you want to actually shop for several of them so that when one is in the laundry or gets lost, you have backups your kids don't know about. We didn't know this. We were inexperienced parents with my first child, and someone gave him this as a present, and we never could find an exact one. There's a gazillion stuffed Peter Rabbits, but none of them look just like this, and he wouldn't have been fooled. So, oh well, we messed up. But we managed to not lose him over all these years, and now he's helping. Okay, so if there's a number line, imagine that, do I have a ruler with me? No, I don't. Okay, well, just imagine there's a number line in front of my desk. I'm gonna turn off screen share. So here's Peter Rabbit, here's my number line. This way is positive, this way is negative. Everyone okay with my picture on my desk in front of me? So if Peter Rabbit does something positive, like we say, let's go 3 scoots to the right, right? 1, 2, 3, that's fine. If we want to say, Peter Rabbit, go 3 scoots to the left, go 3 scoots smaller, then what should we tell him to do?
Move to the left.
Move to left. He's not that smart. He doesn't know his left and right.
Move backwards.
Move backwards, right? You can tell him go backwards 3 steps and he goes to where we want with our decimal point scoots. So forwards or backwards. Okay, how else can he go backwards? We want him to end up here. Other than saying hop backwards, what could we tell him to do?
Lay down.
I have.
We want him to get over here, not take a nap.
Oh, I'm totally using it. Don't you dare challenge.
Scoot, sort of. He'll move the way we tell him. He just doesn't know his left and right.
Hop.
So we want him to wind up here, but we're not going to use the word backwards. What other instructions can we give him?
Towards your coffee cup.
Toward a coffee cup? Close. What I'm looking for is turn around. Right? We could say turn around and then go forward, and he winds up with the decimal scoots to the left kind of thing, right? Okay, so magic moment. What happens if we do both? So Peter Rabbit, you're going to both turn around and go backwards. So he will turn around and he will go backwards. So now he winds up on the big side of my desk. Everyone see that? Okay, so we're about to do that with the math. So we're going to do our last way to make decimal scoots broken. We started with a nice friendly way of we're just multiplying by 10 or 100 or 1,000. Then we said, let's tweak it and divide instead of multiply. That got Peter Rabbit towards my teacup. Then we said, let's, instead of 10, 100,000, we'll use the decimals, tenths, hundredths, thousandths. And that also made him small and get towards the teacup. If we do both backwards things, now we're dividing and we're using the decimals, that's going to make Peter Rabbit go the forward direction. And if you don't trust me, try it on your calculator. But now we're going back to the right, just the way having him turn around and go backwards. They sort of canceled each other out and made things bigger. This is something that will make sense to you right now, probably, but then in week 10, when we're studying for the final, you'll have forgotten it because you don't use it enough and you'll have to go back and study it. So put a little star by your note for week 10 here. So way back in the other slides, when we were doing this garbage, so that now is connected, that scooting decimal points happens. If I wanted to do a really complicated thing now, I could. Let's have the decimal be 2.12, and this one be, I don't know, 6.8. That look good? So we need the same amount. Is one decimal point scoot enough? No, I need another one. So if I'm doing 2 on the top, I'll do 2 on the bottom. I could just be done thinking about it. If I wanted to, I could write a times 100 because we know that's what we're doing. That's as far as we get with those numbers. So you could do something more complicated like Rob asked about. It's just whatever the biggest number of scoots you need is, you have to do that. And since you do it once, you have to be fair and do it on the bottom. Okay, so your homework then is to first look at example problems. Make sure the ones that we've done today you can do when I'm not here. Make sure the ones we skipped over you can do. Try some textbook problems. Go to that page if you're in this book, or if you have the green book, then it has its own numbers because it's a different book. When you've done some of those, then the problem bank is still not much there, but try some of the random problems. Those are the ones that will look like the test anyway, in rounding and in fractions. Percent format, you could try some of these scoots, but we haven't done anything below that. And finally, if you think you're ready, come on. There we go. Then you could do the turn-in problems for rounding, or you could do the turn-in problems for fractions. With our calendar, Then we have a study session on Friday at 3:30. I'm not planning to see you at all tomorrow, but if anyone wants to organize something, then you can. And nothing has an official due date yet. When I see you on Tuesday, I will ask, does anyone have questions on the shape-shifting rounding? And if no one does, then rounding will be due the next class after that. Today, someone did have questions on that, so there's no due date yet. Does that make sense? If people have questions on rounding, then I'll ask again on Wednesday of next week. Do people have questions on rounding? And if they don't, then it will be due the class after that, which would be Monday, and so on. So does anyone know right now, before I say goodbye, 1 minute left, if they want an extra study session other than 3:30 on Friday? No one's saying anything. Okay. The other thing you might want to do that's harder this term than usual is among each other share contact information. Sometimes it's nice just to be working on homework with your phone by you. And I know that whatever, Rob is my study partner. If I'm stuck, I'm going to call him up. Just like it's easier to go for a jog in the morning if you have somebody else that's going to be disappointed if you don't meet them. Then maybe doing homework Thursday night will work better if you have somebody in class that's your study buddy and you're both going to do it for that hour and probably never actually talk. But if you get stuck, then you have somebody and their phone number and you can call them. So I'll send out a part of the after class email that I always do this time will be, by the way, if you want me to share your email and or phone number with people to try and arrange study partners, let me know, because I'm not going to share your contact information unless you tell me to. Oh, and I see people are typing in chat. So there we go. If you want to type your number in chat, then you can. But I would hesitate to do that because that might show up on the Zoom links. So I think if someone actually wanted to go to our website and see the Zoom, then they might get your phone number if you care. Okay. Hang out if you want to. I'm going to very quickly just check in on my kids and then come back. I will stop the recording. Oh, if you haven't said anything in chat, say hi just so we have you for attendance. And that's all for now. So stop recording. I'll be